Bright Tuty. Every student matters.
So let's look at some of the questions. In this question, we need to find whether these 3 points form a triangle, right? And if so, name the type of triangle formed, right? So let's first of all name this point as A, this as B, and this as C, okay? And let's calculate distance AB. What is distance AB? Point A to point B. So what do we do while calculating the distance? Difference of FC say 3 minus minus 2, 5 square, plus difference of ordinates 2 minus minus 3, again 5 square, and then square root, which is equal to 25 plus 25 square root of 50. So AB is equal to root 50, and then we will calculate distance BC. So minus 2 minus 2, minus 4, then we square it, so it will give you 16. Minus 3 minus 3, minus 6 squared will give you 36 square root. So it will give you 36 plus 6 is 42 plus 10, 52 square root. Okay. So we have got AB, we have got BC. Now AC. What is AC? 3 minus 2, 1, squared is 1. 2 minus 3 is minus 1 squared is again 1. So 1 plus 1 square root, so root of 2, right? So we have got all the 3 sides here. Now we just need to comment whether these form a triangle or not, right? So to form a triangle, what is the property? That sum of any 2 sides should be greater than the third side, right? And if you notice, sum of any 2 sides in this is greater than the third side, because if you do root 50 plus root 2, right, these are the smaller sides. So if their sum is greater than root 52, then we can say these form a triangle, right? So if you calculate the approximate values here, you will find that this is greater than this, right? Because this is 1.414 approximately, plus this is 49 is square root of 49 is 7, so 7 point something. And what is root 52? It is 49 plus 3. 52 is 49 plus 3, so it is 7 point something, right? So 49 square root will give you 7. What is 8? 8 is square root of 64, right? And what is the difference of 49 and 64? What is the difference here? It is 15, right? So 52 is closer to 49, so it will nothing but 7 point something, right? But this is 8 point something. Okay, so we can say that sum of these 2 sides is greater than the third side. Hence we are sure that these 3 points, these 3 vertices will form a triangle. Now let us look what kind of triangle it is. As it is evident from these 3 that if I square these 2 and add, I'll get 52, right? If I square AB and AC and add these, what do I get? AB square root 50 square, AC square root 2 square, so it will give me 50 plus 2, right? So it will give me 52, which is nothing but square of BC. So I can write it at BC square. So sum of squares of 2 sides is equal to square of third side, right? So hence we can say this is a right angle triangle. Right? So this is how we will comment on what kind of this triangle this is. First of all, we need to find that sum of any 2 sides is greater than the third side to form a triangle, right? So now this forms a triangle, and then to find what type of triangle it is, we saw that squares of sum of 2 sides is equal to the square of third side. Hence we can say that this is a right angle triangle. Okay. show that these points are vertices of a square, right? We discussed about a square. So let's name these points A, B, C, D. You just need to calculate distances AB, BC, CD, AD first, right? If these are equal, then we can say that this particular quadrilateral is a rhombus. Then you need to calculate the distances of the diagonals AC and BD. If these two are equal to each other, then we can say that this is a square. So these distances should be equal and these two should be equal for it to become a square, right? So you have got an idea about this question. Now let's solve. What is AB? AB is nothing but 4 minus 1 3 squared, 2 minus 7 is 5, minus 5 squared is 5 square itself. So this is 25 plus 9, so root of 34, right? Let's look at BC. Minus 1 minus 4 is minus 5, minus 5 squared is 5 squared, minus 1 minus 2 is minus 3, so it will be equal to 3 squared, right? This is again root 34. What I am doing here is, let's say calculate distance CD. Minus 4 minus of minus 1. What I am doing is minus 4 minus of minus 1, right? It is difference of abscissa. Now you need to square it, right? Even if it was negative, it will become positive, right? So minus 5 squared is equal to 5 squared itself. So this was difference of abscissa. We are calculating distance CD. Now what is difference of ordinates? 4 minus minus 1, which is equal to 5, right? So this is minus 3 squared, which is equal to 3 squared, and this is 5 squared. So again root 34, right? Now let's talk about AD. AD, difference of abscissa, minus 4 minus 1 square plus 4 minus 7 squared. Again this is 5 square plus 3 square, square root, again root 34. So we have proved that the sides are equal, right? Up to now we can say that the sides are equal. Now let's talk about the diagonals here, AC and BD. How much is AC? AC is difference of abscissa, minus 1 square plus minus 1 minus 7 square. So it will be equal to 2 square is 4, 8 squared is 64. So root of 68, right? Let's see what BD is equal to. BD, minus 4 squared plus 4 minus 2 squared. So it will be equal to 8 square is 64, 2 square is 4, so root 68. So the diagonals are also equal. So up till now we have proved that all sides are equal, both diagonals are equal. Diagonals are equal, hence it is a square, right? So this is the way you prove a particular quadrilateral as a square. Okay. Find a relation between x and y such that the point xy is equidistant from these two given points. Let's say these two given points are 7 1, let's name it as A. This is 3 5, let's name it as B, right? There is a point xy which is equidistant from these 2 points, right? The point equidistant from 2 points doesn't have to be the midpoint only, right? The midpoint will obviously be equidistant from these 2 points, but any point lying on this line. What is this line? This line is perpendicular bisector. Perpendicular bisector. So any point lying on the perpendicular bisector is equidistant from these 2 points. Let's take this point as xy, right? So xy is equidistant from A and B. So we just need to show using the distance formula that these distances are equal. Let's name it as C. So as per the question, AC is equal to BC, right? Let's use the distance formula now. So x minus 7 squared plus y minus 1 squared square root is equal to distance BC. What is distance BC? 3 minus x squared plus 5 minus y squared, right? These two distances are equal. Now we need to find a relation in x and y. So square both sides and open these brackets. So x minus 7 square will be x square plus 49 minus 14x plus y square plus 1 minus 2y is equal to 9 plus x square minus 6x plus 25 plus y square minus 10y, right? So you notice that x square is cancelled with x square, y square is cancelled with y square here, right? This is minus 14x, this is minus 6x. If I bring this 14x to the right hand side, it will give me 8x, right? So these two terms are taken care of. Now let's look at y terms. This is minus 2y, it will come on the right side as 2y, so minus 8y, right? So this is taken care of, this is taken care of. Now 49 plus 1 is 50, so 50, and how much is this? 25 plus 9, 34. So you subtract 34 from here, so it will be equal to 16. So 8x minus 8y is equal to 16. Hence you can say that x minus y is equal to, you divide both sides by 8, is equal to 2, right? So this is the required relation, right? We had to find the relation between x and y. So this is the relation between x and y, right? And this is a equation of a line, right? So I explained in the beginning that this is a perpendicular bisector. Every point lying on this perpendicular bisector is equidistant from A and B, right? We did it in class 9th using the congruency, right? If you draw a perpendicular bisector, what will happen is, this is a bisector, so this part is equal to this part, right? This angle is 90 degrees, right? Because this is a perpendicular bisector, and this side is common, right? So side angle side congruency will make these two triangles as congruent. Hence this side will be equal to this side. Similarly, this side will be equal to this side, or any point on this line, any point you take, always there will be a congruency. Hence this distance will be equal to this distance, right?